There are three types of plate boundaries: divergent, convergent, and transform. Divergent boundaries are plates that are moving away from each other, and they can either be oceanic plates, like the one shown here, or you can have a divergent boundary with continental plates. At a divergent boundary, as the plates pull apart, hot molten material, magma, rises up to the surface, causing volcanic activity. When a divergent boundary is on the ocean floor, a mid-ocean ridge is formed. That's the Earth feature that we can see. When a divergent boundary is on a continent, a rift or a continental rift is formed. And again, that's the Earth feature that we see. There are continental rifts in Africa and in Central America, and mid-ocean ridges run down the center of all of Earth's oceans. This map shows the age of the oceanic crust. The red color, you can see the red color, shows the youngest aged rock, and the blue color shows the oldest aged rock, about 200 million years old. So where are the ocean ridges located? Or where are the divergent boundaries? The divergent boundaries are where the plates are pulling apart and new material is being produced. Therefore, ocean ridges are in the middle of the red material, because red is showing the youngest rock, so new magma is being pushed up as these plates are being pulled apart. Everybody take a look right here. This is Iceland. So why is Iceland so interesting? Well, if we look closely, the mid-Atlantic ridge, which runs down the middle of the Atlantic Ocean, runs right through Iceland. In fact, Iceland exists because of this divergent boundary, as the North American plate and the Eurasian plate pull apart. Volcanic activity occurs along the cracks and fissures that are formed. As many eruptions have occurred over time, the island of Iceland has been formed. The next type of boundary is a convergent boundary, and there are three types: continent-to-continent plate collisions, continent-to-oceanic plate collisions, and ocean-to-ocean plate collisions. So we're going to talk about each one of these. When continental crust pushes against continental crust, both sides of the convergent boundary have the same properties. Think back to the description of continental crust. It's thick and buoyant. That means that neither side of the boundary wants to sink beneath the other side, and as a result, the two plates push against each other and the crust buckles and cracks, pushing up high mountain ranges and pushing down into the mantle. For example, the European Alps and the Himalayas have been formed this way. India used to be an island, but about 15 million years ago, it crashed into the Eurasian plate. As continental crust was pushing against continental crust, the Himalayan mountain belt was pushed up. Mount Everest is the highest altitude mountain on our planet, standing at about 29,864 feet high. And it's still growing because the Indian plate is still pushing into the Eurasian plate. Some convergent boundaries occur where continental crust pushes up against oceanic crust. The oceanic crust is thinner and more dense than continental crust, and therefore it sinks below the continental crust. This area of sinking where the two plates meet is called a subduction zone. The oceanic crust descends into the mantle at a measurable rate, sometimes 2 to 3 centimeters per year. Melting magma rises up into the overlying continental crust and forms volcanoes. Subduction is a way of recycling oceanic crust. If you think about it, oceanic crust is being formed over here at a mid-ocean ridge. It's being pushed across the ocean floor and eventually runs into a continental crust. When it runs into that continental crust, it's subducted back into the mantle, remelted, and over billions of years can erupt again at another mid-ocean ridge. The Andes mountain range along the western edge of South America is an example of a mountain belt formed by subduction. We can see here the South American plate, which is continental plate, is pushing up against the Nazca Plate, which is in the middle of the Pacific Ocean, and this plate boundary forms the Andes Mountains. The last type of convergent boundary is an ocean-to-ocean plate collision. Now, in this case, both plates have the same properties. They're thin and they're dense, which means that they both want to sink, but they both can't sink. When two oceanic plates converge, one runs over top of the other, causing it to sink into the mantle and form a subduction zone. And the feature that we see on Earth at a subduction zone caused by two oceanic plates meeting is a trench. Trenches are extremely deep. They're some of the deepest places on Earth. The Marianas Trench, for example, is located off the coast of Japan and is 11 kilometers deep. And this is the Puerto Rican Trench, which is off the coast of Cuba and the Virgin Islands, and it's extremely deep. Amazing, unique life forms can be found at the bottom of the trenches, but we have not explored them very much because they're so deep. The last kind of boundary that we want to talk about is a transform boundary, where two plates slide past each other. The best example of this is the San Andreas Transform Fault out in California, and it runs right through San Francisco.